So welcome to the another lectures. As previous lecture, we deals in the topic of parallel connection of resistors, which we need to talk after after this topic. But we previously talked about the connection of parallel combination of resistors. And so today our topic is on resistance. Okay, basically what is resistance and what is the uh, formula of resistance and what are the factors that affect the resistance, including what are the role of resistance in electrical circuits. Okay, so we will discuss these various things in procedure or step by step in this lecture. So let's deal to the our topics with resistance. Means resistance means as we know they are defined in various ways. Okay, they are defined in various ways, but the basic or fundamental need to concept we need to know is that the opposition of current flowing through an electrical circuit. Okay, the opposition of current flowing through an electrical circuit is termed as resistance. Okay, so it mean to be resistors, but the property of resistors means the property of resistors is called resistance. The property of resistor which oppose the flow of electric current is termed as resistance. Okay, now the resistance of a conductor is directly proportional. Okay, resistance of conductor is directly proportional to the length of conductor. As we know, this is the main formula for find the resistance of any circuit. This is the basic formula, which is R equals to rho upon L, rho L by A, L upon A. That means resistance, which terms resistors of conductor directly proportional to the length. This R resistance is directly proportional to the length. Okay, and inversely proportional to the cross sectional area, and R is inversely proportional to cross sectional area, which mean to be that R directly proportional to L, and another R inversely proportional to cross sectional area. Means these two things need to remind. Okay, hence R, and this is the, and this rho is the resistivity of conductors. Okay, rho is the resistivity of conductors. So by formation of this, R equals to rho L by L upon A, means length upon cross sectional area, which is the formula of resistance. Okay, now these above things are written here. R equals to resistance of conductor. Okay, which is in ohm. Okay, mu is rho is equal to resistivity of conductor, which is in unit ohm meter. Okay, L is equal to length of conductor, which is in meter, and area A equals to area of cross sectional, which is square meter. Okay, now this is the formula and the resistance definition. Now another thing is that what is conductivity or conductance. Okay, reciprocal of resistance is conductivity. Similarly, likewise, reciprocal of resistance is conductance, which is which is denoted by G. G means basically conductance. G equals to what, according to our definition, reciprocal of resistance, 1 upon R equals to conductance. Okay, and conductivity mu is equal to 1 upon resistivity. Resistivity, which this upon this upper rho is called resistivity, 1 upon rho is conductivity. Okay, understand. Now as we know, in electrical circuit, resistance of conductor also depend on temperature. When the flow of current is opposed or blocked, then as proportional to the resistance blockage, there increase in a temperature. So this term refers to that resistance of conductor also depend on temperature. when the resistance will be uh, created, then the temperature will also rise. Resistance increases with increasing temperature. When resistance will increase, okay, then temperature will also increase. Resistance will increase, then the temperature will also increase, because is because it block the flow of electric current. Or likewise, for example, it blocks the flow of continuity of electrons flowing in a circuit, so that's why the temperature get also rise. Okay, the higher temperature be, let this derivation, this equation made for the above, the higher temperature be T2. T2 means the higher temperature, and the initial temperature, lower temperature be T1, and it can be expressed as, this is also studied in the physics formula in physics. Okay, in heat and thermodynamics. So R2 equals to R1 brag 1 upon alpha T2 minus T1. This is the resistance and the temperature relation formula. Okay, so now where the R2 termed as resistance at temperature 2 T2, temperature at T2, R1 similarly temperature at T1, and alpha temperature coefficient of resistance at T1. Okay, temperature resistance at T1. But now what we think need to be see that resistance of semiconductor insulator decreases with increasing temperature. Okay, now here what, if the resistance will increase, then the temperature will decrease. In which case, in semiconductor. Okay, in semiconductor and insulator case, in semiconductor and insulator case, when the resistance will increase, then the temperature get decrease. This is termed as air. But resistance of semiconductor and insulator decreases with increase in temperature. Okay, now there are the basically three roles of the resistance in a circuit. Okay, first one is limiting current. Okay, first one is limiting current. How we can tell that it limits current? Okay, it limit the amount of current flow through the circuit, because resistance have the nature in that it's follow or limit the amount of current through the circuit. And according to the Ohm's law, okay, in Ohm's law, if the voltage in a circuit remains the same, the current will be decreases if resistance increases. Here from this relation, R equals to V by I from Ohm's law. Okay, from Ohm's law, current will decrease if resistance increase. Current will decrease if resistance will increase, because they are inversely proportional to each other. Okay, now dividing voltage. It can be, its main role is that to divide the voltage, and resistance can be used to reduce the volt to a level that appropriate for the specific part of any circuit. Okay, hence the last one is heating element. Heating element means the application, basically, that is electric heater, iron. All these are heating elements works on the fundamental principle of resistance. Okay, resistor block the flow of current. Okay, and hence electrical power loss in it is generated as heat energy. Okay, when it blocks the flow of current, then the heat energy is produced. And by this principle makes electrical heating equipment such as electric iron and many more filament lamp to be glow. So the resistor is also used for heating elements. So today only up to this much. Now another topic will be discussed in another lecture. So thank you.